Hello everyone, this is the second video of chemical bonding, and in this video we'll be starting our class with one question. Atomic number of 4 elements. These elements are A, B, C and D are respectively Z-1, Z, Z+1 and Z+2. This is the atomic number. If Z is equal to 9, what is the type of bonding? What is the type of bonding? First part is A and D. Second part is B and D. Third, A and A. And the fourth one, B and B. So this is our question. Atomic number of 4 elements A, B, C, D is Z-1, Z, Z+1, Z+2. तो बताइए what is the type of bonding between A and D? So first of all, we'll see if Z is equal to 9, so Z-1 will be 9 minus 1, right guys? So this will be 8, this will be 9, this will be 9 plus 1, that is 10, this is 9 plus 2, 11. So tell me which element has the atomic number 8? Sing the song. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, right? So that means what is A? A is oxygen. What is 9? Very good. B is fluorine. What is C after fluorine? Argon. Very good. And then what is D? It is sodium. Now what is oxygen? Oxygen is a non-metal, right? Fluorine is a non-metal. Argon is a noble gas. And sodium is a metal. Now what is the type of bonding between A and D? So what is A? A is oxygen. So oxygen and sodium. Sodium is metal. This is non-metal. So metal forms ions, cations. Non-metal forms anions. Cation and ions forms ionic bond. So the first answer is ionic bond. Yeah, ionic bonding. B and D. B is fluorine and this is sodium. So again, metal and non-metal, cation and an ion. And again, sodium fluoride. This will be sodium oxide. So this will be again ionic bonding. Right, guys? A and A, oxygen and oxygen, two non-metals. What type of bonding is this? Covalent bonding. The bonding happening between by the sharing of electrons, usually between non-metals, is called covalent bonding. B and B, fluorine and fluorine, F2 gas, this is O2 gas, again covalent bonding. Okay, guys. Okay. If this would have been a normal classroom, then I would have erased what I had written on the board. So now I'm erasing it. And if you're not able to copy it, you can pause the video and you can solve it and write it down in your notebook. So my advice is, if you are really going through my videos and actually trying to study, so watch the video by keeping a notebook and a pen with you. Write down with it and then do the exercises simultaneously. Okay? And in many of the classes that I take, when I ask students to rub the board, so the tallest guy or the girl, they come forward. So if those students of mine who are attending my classes online, and if they would have taken the real classes with me, then we would have enjoyed a lot. Like we would have interacted better, we would have known better, we could have also partied together. Because I remember when I used to take classes, the students and I used to have a lot of fun activities. So in online classes also, I'll always share my experience, and I'll always keep telling you ki how you should go about the studies and how you should be living your life and how you can do better as a person, as a student, as a kid, and as a citizen of India. So yeah, there are so many aspects of life. Okay, third question. Substance X has a melting point of 500 degrees Celsius. Substance X. It conducts current at room temperature. It conducts current at RT. Substance Y. Okay, substance Y is a gas at room temperature. It does not conduct current. Substance Z is soluble in water, and the solution conducts current. Solution conducts current. However, in solid state, Z does not conduct current. Solid state, no current conduction, okay? But melts as 1020 degrees Celsius to form a conducting liquid. Deduce whether X, Y, and Z have which of the following? Have giant or molecular structure, are bonded covalently or ionically. So guys, we have, because we are learning about bonding. So by looking at these characteristics, what can we say about these type of compounds? So the first one, X. Okay. Melting point is 500, conduct current at room temperature. Very high. Melting point conducts current at room temperature. So what can you say about X? That means it can have a giant or molecular structure. Why? Because in case of metals, if you're thinking of metallic bonding, my dear friends, just think about it. It conducts current at room temperature. That means, and the melting point is not that high, it's just 500 degrees Celsius. So it has to have a giant molecular structure. Giant molecular structure. If you are able to think about of such compound, and if somebody is thinking of graphite, then very good. And what type of bonding exists? Graphite is a allotropic form of carbon, and it has covalent bond, right? Now the Y, if we look at the characteristic of Y, it is gas at room temperature, it does not conduct current. So typical non-metallic character, right? Or it could be any of the gas like O2, F2. So they are, what type of compounds they are? They are covalent compound. Covalent compound. Y is a covalent compound. Now Z is soluble in water, solution conducts current. And in solid state it does not conduct current. A typical characteristic of ionic solid, like common salt. The solid common salt, solid NaCl does not conduct electricity. If we take solid NaCl in a bowl and we try to put our wire into it via battery, so the bulb will not be lit. Why? Because in the solid state, in ionic solid, ions are not free. Therefore, there is no conduction of electricity. But when you dissolve that ionic compound like NaCl in water, the ions get dissociated. So that now ions are free to move. Therefore, they conduct current. And one more important characteristic of ionic solids are they have high melting point. So therefore, what can we comment about Z? That Z is a ionic compound or ionic solid. Okay, guys. Very good. Now, what are the factors which favors the formation of ionic bond? Ionic bond बनाने के लिए what are the different factors? So first of all, for the ionic bond formation, we need to have a cation, we need to have an anion, and when cation and anion combine, they combine to form crystal lattice. What is crystal lattice? A three-dimensional array of arrangement, a regular arrangement of cation and anion is called crystal lattice. If you're not able to understand this, we can take typical example of Na plus Cl minus. So there is a force of attraction between these two. They come together. And when we talk about ionic solid, तो भाई एक cation और एक anion तो होगा नहीं. एक पूरे ionic solid में बहुत सारे cations, बहुत सारे anion होंगे. तो इनकी अरेंजमेंट सिर्फ एक डायरेक्शन में तो होगी नहीं. फोर्स ऑफ अट्रैक्शन हर डायरेक्शन में होगी, नहीं होगी भाई. देख लो इस तरह से भी होगा, पीछे की तरफ भी होगा, इस तरफ भी होगा. So there is a three dimension. Then this will be further connected to next sodium. So this type of arrangement is there. So this regular arrangement is called crystal lattice. अब अगर हम typical example समझे बच्चों, if we take a typical example of ionic bond formation, तो सबसे पहले क्या करेंगे कि हमें कोई एक सॉलिड लेना है, सॉलिड mx. मैं आपको एक एग्जांपल समझा रही हूँ. A very simple example of formation of a ionic solid mx, where m is the metal and x is the anion. So first of all, what we'll get? You know, usually metals are present in the solid state, right? Sodium is a solid, iron is solid, and potassium is solid. But the non-metals like oxygen, chlorine, bromine, these are gaseous. Okay, so these are called the. I'll tell you this one important thing about it. You'll see these are called their. You'll read about it in your thermodynamics, but let me not introduce it at this stage, otherwise you'll get confused. So in order to form the lattice, so M is usually present in solid form, right guys? So first of all, what will happen? This solid has to be converted into M gas. Why? Because when you react something, something has to be reacted in an active form. So when the solid is converted into gas, what type of process it is? It is called sublimation. So we can say the energy change or the enthalpy change for this is sublimation. Next step will be this metal gas will try to lose one electron and become Mg plus. And when the electron is lost, what do we call it? Ionization. So we call it ionization energy, ionization enthalpy or energy. We call it enthalpy in thermodynamics or energy. For the time being, we can call them interchangeably. It's one and the same thing. I was talking about the standard states. I'll introduce it. Now, what will happen in case of halogens or the nonmetals? They are in their standard state. They are present in the gaseous form, in the diatomic state. So first of all, they'll be converted into this. And what do we call this? We call it bond energy. The bond between 2x atom is means one molecule of x2 is broken down into two atoms of x. What do we call it? We call it delta H bond dissociation energy. Now this X gas will be converted into anion by gain of electron. So what do we call it? We call it electron gain enthalpy, electron affinity, electron gain enthalpy. The name is self-explanatory. The enthalpy used to gain the electron. Now anion is formed, cation is formed, right kids? Now they will react. Now I'm talking about this entity will combine with this. So this will form Mg plus gas, X minus gas will form Mx gas, or we can say Mx solid. This is called, when we talk about Mx solid, that means it's called lattice energy because solid is forming. This is a little bit basics. I'll talk about the chart which is called Born-Haber cycle. So this is the introduction of just Born-Haber cycle. So what is lattice energy? Lattice energy is of an ionic solid is defined as the energy required to completely separate 1 mole of solid ionic compound into gaseous constituent ions. Look at this equation that I've written. This is solid. अब इसका उल्टा देखो. अब इस mx solid से अगर मुझे mg plus गैस x minus गैस मिल जाए तो इसको क्या बोलेंगे हम? लेटिस एनर्जी. तो जितनी एनर्जी रिलीज होती है जब mg plus गैस x minus गैस कंबाइन होकर mx solid बनते हैं, उतनी एनर्जी लगेगी जब मैं इस mxx को तोड़ना चाहूंगी. उल्टे प्रोसेस में अगर एक सीधे प्रोसेस में एनर्जी मिल रही है तो उल्टा प्रोसेस करने में खर्च करनी पड़ेगी. आप ऐसे समझ सकते हैं, जब आप व्हेन यू ट्राई टू मेक आइस, ओके, व्हेन यू ट्राई टू कूल डाउन द वाटर, आप उसको फ्रिज में रखते हो और जब उसे बाहर निकालते हो टेम्परेचर राइज होता है, वो मेल्ट हो जाती है. तो उल्टा प्रोसेस है. व्हेन यू आर ट्राइंग टू मेक आइस फ्रॉम liquid to solid, you are putting it in the fridge. When you have taken it out, you have increased the temperature now from solid to liquid. So opposite process. So if I say when mx gas and xz minus gas, they combine, a positive and negative, they combine to form mx solid. The energy is released. This is called lattice energy. And when mx solid, similarly the same energy will be released. Suppose here x amount of energy is released, so here will be minus x amount of energy. उल्टा साइन है, जितनी खर्च हुई उतनी रिक्वायर्ड होगी. So let's talk about Born-Haber cycle and why do we need it. Okay. For example, lattice energy of NaCl, lattice energy of NaCl is equal to 788 kilojoule per mole. What do we mean by this? That means 788 kilojoule of energy is required to separate 1 mole of solid NaCl into 1 mole of Na plus gas and 1 mole of Cl minus gas to an infinite distance. To an infinite distance so that they don't have the force of attraction between cation and anion. This is the definition. But how do we understand it? आपके पास solid NaCl है, आप इतनी एनर्जी प्रोवाइड करो सॉलिड NaCl को कि 1 मोल NaCl आपने सॉलिड लिया है, उसका इतनी एनर्जी प्रोवाइड करो कि वो पहले लिक्विड बने, फिर वो गैस बने, गैस बन के उसके अंदर से एटम्स रिलीज हो और उन एटम से हमें क्या प्राप्त हो? Na plus gas and Cl minus gas. This is lattice energy. Now lattice energy, understand what I'm trying to say. When I say Na plus gas, Cl minus gas, they combine to form NaCl. The positive is coming closer to the negative. There will be a strong force of attraction. So what will happen in this case? Energy will be released in this process. And energy released is always shown in the negative sign. So we call it delta H, lattice energy, and it is negative always. Why? Because when positive and negative combine, obviously it's a very natural process. When the positive cations, they attract or get combined with the negative anions, they're happy and they release a lot of energy. Yes or no? When we are made to sit in our class with our best friends, so obviously we like that person, so there's a good friendship between us. So yeah, we are happy. So it's a lot of happiness is released, similarly the energy is released. Take one more example. In case of magnesium, magnesium 2 plus ion combined with 2 Cl minus ion to give MgCl2 solid. Yes or no? In case of aluminium, aluminium 3 plus not aqueous, I meant gas. Gas combined with 3 Cl minus gas, AlCl3 solid. This is lattice energy. Now, what are the factors affecting lattice energy? Just now we have studied lattice energy is the energy released when the gaseous cation and anion combine to form 1 mole of the solid. Le by that I means lattice energy. अब lattice energy क्या होगा? Lattice energy उतनी ही ज्यादा प्रोपोर्शनल होगी जितना डिस्टेंस कम होगा, जितने कैटायन आयन पास आएंगे उतनी ज्यादा लेटिस एनर्जी रिलीज होगी. सो वी कैन से इंटर आयनिक डिस्टेंस है वो इनवर्सली प्रोपोर्शनल होती है. फर्स्ट फैक्टर इंटर ionic distance. So you can say lattice energy is inversely proportional to radius का square. If you are aware with the physics, आपने पढ़ा होगा between the two opposite charges, the energy is inversely proportional to the distance between the square of the distance between them. Second factor is the lattice energy is directly proportional to the charges. जितना ज़्यादा charge होगा उतनी ज़्यादा lattice energy होगी. For example, in case of NaCl and magnesium chloride. So in sodium we have Na plus and magnesium we have Mg2 plus. किसका charge ज़्यादा है? Who is having greater charge? जितना ज़्यादा charge होगा, greater the charge, more will be the lattice energy. So guys, tell me which one has the higher lattice energy? Magnesium chloride. You're right. Very good. दूसरी चीज अब हम समझ सकते हैं. The third factor is coordination number, Cn in short. So the lattice energy is directly proportional to the coordination number. Coordination number of cation is the number of anions surrounding the cations. Coordination number of anion is the number of cations surrounding the anion. अब ऐसे समझिए. If I have a cation and I have the greater number of anions attached to it, so the more anions attached to the cation, that means more attraction, that means more lattice energy. अब suppose I have two solid जिसमें एक cation से दो anion जुड़े हैं, दूसरा solid जिसमें एक cation से चार anion जुड़े हैं. तो जिसमें चार anion से cation जुड़ा है वो ज़्यादा lattice energy देगा, because there will be more forces of attraction. If you're not able to understand what do I mean by this, so when we'll do the comparison exercises, then you'll understand what do I mean by coordination number. So it says the coordination number factor is important only in cases of sulfates and carbonates of alkaline earth metals, and coordination number is calculated by experimentally or by radius ratio. ये आपको ध्यान रखना है. जैसे हम डाउन द ग्रुप की बात करते हैं, हम अगर सेकंड ग्रुप की बात करें, so we have barium sulfate, we have magnesium sulfate, we have calcium sulfate, we have strontium sulfate, and we have barium sulfate. अब इसमें क्या होता है? What is the order of lattice energy? The lattice energy is higher for barium. It goes in this order. Why? Because down the group the size of the cation is increasing, right? Size of cation is increasing down the group. अब जैसे जैसे size of cation बढ़ेगा उससे ज़्यादा anion आके जुड़ पाएंगे. So we can say the coordination number of that cation increases, hence the lattice energy increases. And Guys, if you're not able to understand this coordination number wala concept, I have a shortcut for you. Understand, sulfate is a larger anion, is a bigger anion, and there is a more force of attraction when a bigger anion combines with a bigger cation. आप ये खुद समझिए, जब आप 6th क्लास में हैं तो आपकी दोस्ती एक 6th क्लास वाले स्टैंडर्ड वाले बच्चे से बहुत अच्छी होगी. Although exceptions are there, I'm just giving you one random example, but वही एक 12th क्लास के बच्चे से आपकी इतनी अच्छी दोस्ती नहीं हो सकती, क्योंकि आपको पता है वो आपसे बहुत सीनियर है. एक 12th क्लास के बच्चे की दोस्ती अपने 12th स्टैंडर्ड वाले बच्चे से बहुत अच्छी होगी, बिकॉज यू हैव सो मेनी कॉमन थिंग्स. सिलेबस भी सेम है, पढ़ाई भी सेम है, क्लासेस भी सेम हो रही हैं. सो बिकॉज डाउन द ग्रुप बेरियम का साइज बढ़ता है. डाउन द ग्रुप जाते जाते बेरियम इज द लार्जेस्ट कैटायन इन द सेकंड ग्रुप. तो एक लार्जर एनायन से वो बहुत अच्छे से कंपेटिबली कंबाइन करेगा. जब वो कंपेटिबली कंबाइन करेगा तो उसके अंदर स्ट्रॉन्ग फोर्सेस ऑफ अट्रैक्शन होंगे. स्ट्रॉन्ग फोर्सेस ऑफ अट्रैक्शन होंगे तो उसकी लैटिस एनर्जी ज्यादा होगी. राइट? One more thing. You can pause the video if you had not written down this order. You can always pause my video and write it down in your notebook and understand the concept. Then the chemistry will become easy for you. अब मान लीजिए मेरे पास साइज है और चार्ज है. किसको फैक्टर को जो करें? So if we have the same size and the charge will dominate. Example, sodium oxide, sodium fluoride. Between these two, guys, between sodium oxide and sodium fluoride, which one has higher lattice energy? सोडियम में साइज सेम है. ऑक्सीजन का जो ऑक्साइड है उसके ऊपर 2- चार्ज है. इसके अंदर O2- है, इसके अंदर F- है. सोडियम सोडियम कॉमन है. तो अब बताइए, और अगर हम साइज की बात करें तो ऑक्सीजन और फ्लोरीन के अंदर जो साइज का डिफरेंस है, जब हम ऑक्सीजन टू फ्लोरीन जाते हैं तो साइज क्या होता है आयन का? क्योंकि इलेक्ट्रॉन सेम शेल में ऐड होता है तो क्या होता चला जाता है? रिपल्शन का साइज बढ़ता है. तो हम इसको ऐसे याद कर सकते हैं, क्योंकि इसमें ज्यादा चार्ज है ऑक्सीजन में, तो इसकी लैटिस एनर्जी क्या होगी? ज्यादा होगी. चार्ज डोमिनेट्स ओवर साइज. एक और एक्सरसाइज देखते हैं. सोडियम क्लोराइड, सोडियम फ्लोराइड. बताइए किसकी लैटिस एनर्जी ज्यादा होगी? अब चार्ज सेम है, साइज किसका छोटा है? सोडियम से क्लोजर किसका साइज है? सोचो. और एक और एक्सरसाइज देख लीजिए. NaCl, सोडियम सल्फाइड. अब क्या है? साइज तो ऑलमोस्ट सेम ही जा रहा है क्लोरीन एंड सल्फाइड का, क्योंकि सेम ही, जैसे क्लोरीन का एटॉमिक नंबर 17 है, सल्फर का 16 है. साइज का तो डिफरेंस नहीं है, बट चार्ज इसके अंदर S2- है, Cl- है, तो चार्ज किसका ज्यादा है? इसलिए सोडियम सल्फाइड का लैटिस एनर्जी ज्यादा है. आपको जब ध्यान रखना है, जब चार्ज सेम है तो साइज को डोमिनेट कर दीजिए. जब साइज ऑलमोस्ट सेम है तो चार्ज को डोमिनेट कर दीजिए. और साइज और चार्ज में से चार्ज हमेशा डोमिनेट होगा.